Hi one and all. So in the previous video I have specified where a student can find the resources for the course called Digital Design Lab, right? So remember, this is the URL or the address that you need to use in order to find the resources for the course called Digital Design Lab, right? So in this video we shall start with the fundamental experiment which falls under part A. I mean, we are starting with the hardware experiment first, and then after this we shall start with a software experiment. The first experiment or the basic or fundamental experiment which comes first in part A is titled as logic gates. The main aim of this experiment is to study and verify the truth table of logic gates, right? So in this video I will cover the theory part which is needed to carry out this experiment, and then in the next video I will demonstrate how we can able to study and verify the truth table of logic gates, right? So I hope you have heard the word called logic gate either in PUC or in theory classes. A logic gate, as the name itself says, can be defined as is basically an electronic device which will perform a logical operation, right? Means it is a device which can take one or more number of inputs and it can produce a single bit as an output. Clear? Okay. The logic gates that we will study in these experiments are AND, OR, NAND, NOR, XOR and exclusive of NOR, right? Clear? Okay. And remember in the market or in the society, usually people will not call logic gates as AND or NAND. Instead they will use some numbering system like this: IC 7400, IC 7408, like this. Means remember, every logic gate has been assigned with a unique IC number. Clear? An example for this is like every student in our college has been assigned with a unique USN, right? For what purpose? For identification purpose, right? Similarly here, every logic gate has been assigned with an unique number. We call that number as an IC number. Clear? So this is IC 7400 is an IC number for NAND gate. IC 7408 is an IC number for AND gate. 7432 is an IC number for 2 input bit OR gate. Similarly, 7402 is an IC number for 2 input bit NOR gate. This is for one input bit NOT gate. This is for 2 input bit exclusive OR gate, and this is for 2 input bit exclusive NOR gate. Clear? So in future we will not call the logic gates as AND, OR, NAND, NOR, XOR, exclusive NOR. Instead we shall use IC numbers, or make it simple, numbering system. Clear? So before coming to pin diagrams, we shall go through the logic symbol or Boolean expression and the truth table of respective gates. See, as I said, we shall first start with the NAND gate first, whose IC number is 7400. As I said, this is 7400 is an IC number for 2 input bit NAND gate. Clear? 2 input bit NAND gate. Why I am calling it a 2 input bit? Look at here, because this gate is taking 2 inputs. One input is called as an A and another input is called as an B, and this is the logic symbol for NAND gate. Clear? And here this line represent an output line. The another way to represent an NAND operation is like this. I mean Boolean expression. The another way to represent the logic gate or operation of logic gate is by using a Boolean expression. We call this as an Boolean expression. So I think you have heard this word even in PUC or in theory classes. We shall come back to this in the coming classes. Or we can use a logic symbol to represent a logic gate. Clear? And this part is a truth table for 2 input bit NAND gate. Usually truth table will have first input section, then output section. In this case, since this NAND gate is taking 2 inputs like A and B, the input section will have 2 columns, one for A, one for B, and it is producing one single bit as an output. We have labeled that as a C. So C will be in output column. Clear? Okay, and what is the use of this truth table? What is the use of this truth table? See, this truth table will help us how actually this logic gate will or electronic device will work. Means if I supply 0 as a value for A and 0 as a value for B, then I can get 1 as an output according to this row. Clear? Similarly, if I supply 0 as a value, 1 as a B value, then I will get C value as 1. If A value is 1, then B value is 0, then output will be 1. If both inputs are 1 1, the output will be 0. See, this is the advantage of truth table. It helps us how actually this electronic device, I mean logic gate, will work. Clear? And how many number of rows should be there in the truth table depends on how many number of inputs that logic gates will accept. Clear? So since this gate or logic gate is accepting 2 number of inputs, how many number of rows will be there in the truth table? 2 to the power of 2. It is nothing but 4. So 4 rows will be there in the truth table. So this is the formula that you need to remember while writing the truth table by looking at either the Boolean expression or the logic symbol. Clear? So generally if the logic gate is accepting n number of inputs, means the number of rows in the truth table will be 2 to the power of n. Clear? And now with this we shall go ahead with we shall go ahead with one more logic gate, and the same explanation will holds good for other logic gates. Clear? So I will explain. We shall go with one more basic gate called AND gate. So this is the IC number for 2 input bit AND gate 7408. Clear? And this is the logic symbol for 2 input bit AND gate, and this is the Boolean expression for 2 input bit AND gate, and this is the truth table for 2 input bit AND gate. So according to this truth table, okay, as I said, it helps us to understand how this logic gate will work, right? Means if I supply 0 0 as an input, output will be 0. 0 1 as an input, output will be 0. 1 0 as an input, output will be 0. Then AND gate will produce us 1 as an output only when both the inputs are high. This is what we can get from the truth table of AND gate. Clear? So like this you have to go through all these gates one by one. Okay, first understand the logic symbol, Boolean expression. Okay, logic symbol, Boolean expression, logic symbol, Boolean expression. Then understand the operation of the respective gate with help of the truth table. Clear? So once you have this understanding, then you need one more important understanding or information. So before going ahead with the hardware experiment is nothing but pin diagrams. So this is our very important. Pin diagrams are nothing but it will shows the internal structure of a logic gate. Clear? So here this diagram is showing the internal structure of a logic gate whose IC number is 7408, which is nothing but 2 input bit AND gate. So this is a pin diagram for the logic gate, 2 input bit AND gate. So see here, look at here. So what actually this pin diagram tells to us? So pin diagram will give information about how many number of pins actually it is. The logic gate is, right? So pin number 1, pin number 2, 3, 4, 5, 6, and this is pin number 7, 8, 9, 10, 11, 12, 13, 14. So from this, your first information what you should be kept in your mind is, so totally it is of 14 pin chip. It is 14 pin chip. And second thing that you need to remember is, usually the pin number will be given in the anti-clockwise. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like this. Clear? So that is the second point of information that you need to know. And one more important piece of information that you should know is about the basic pins, or pins for basic connections. Look at here, pin number 7 is for ground supply, and pin number 14 is used for voltage supply. VCC stands for voltage supply, means we need to supply voltage at this pin and we need to supply ground at pin number 7. Clear? So, and last but not the least, you should get one more piece of information from this pin diagram is one IC will have 4 2 input bit AND gates, right? So this is one 2 input bit AND gate, right? And this is another 2 input bit AND gate, and this is another 2 input bit AND gate. Similarly, this is another 2 input bit AND gate. So this is what I said. So remember, one IC will have 4 2 input bit AND gates. So if I go one by one, so if I take first 2 input bit AND gate, pin number 1 and pin number 2 will be the input pins for the first 2 input bit AND gate, and pin number 3 will be the output pin. Similarly, in case of second 2 input bit AND gate, 4 and 5 are inputs, 6 will be the output. In case of 3, 9 and 10 are inputs, 8 will be the output. In case of fourth one, 13, 12 are input, 11 will be the output. So all these information will be given by the pin diagrams. This is very, very important if you want to study this gate practically. Clear? I hope you understood what is the purpose of pin diagrams. Clear? So similarly, see, this is the pin diagram. This is the pin diagram for 2 input bit OR gate, whose IC number is 7432. Again, look at here. It is a 14 pin IC, right? 1, 2, 3, 4, 5, 6. Again, this is pin number 7, 8, 9, 10, 11, 12, 14 pin, and pin number 7 for ground supply, pin number 14 for voltage supply. And one IC will have how many 2 input bit OR gate? Totally 4. Clear? So similarly you have to go through all the pin diagrams. This is the pin diagram for a NOT gate. I mean, the difference here it is, again it is a 14 pin IC, but the difference here it is, see, one IC has how many NOT gates? 1, 2, 3, 4, 5, 6. So 6 NOT gates will be there in one IC. So that is the difference that you can give with respect to 7432, 7432 or 7408. Like this, you have to go through all the pin diagrams one by one. Clear? One by one. If I like this is a pin diagram for what? For NOR gate, 2 input bit NOR gate, and this is the pin diagram for 2 input bit NAND gate, and this is the pin diagram for 2 input bit XOR gate. Clear? And this is for NOR gate. And look at here, this is interesting. In case of NOR gate, you should remember this. In case of NOR gate, once again it is a 14 pin IC, but see here, look at the direction. The pin number 2 and 3 here, it is act like an input pins, and pin number 1 will act like an output pin. Clear? Similarly, 5 and 6 are input pin, 4 output pin, 8, 9 are input pin, 10 output pin, 11, 12 are input pin, 13 output pin. So one IC will have 4 NOR gates. So like this, you should go through each and every pin diagrams of each and every logic gates, and you need to understand the internal structure of it. So once you understand the internal structure of it and its truth table, you can go ahead with the experiment. I mean, you can start with the experiment part. Clear? So I hope you understood the theory component. In the next video, I will explain how we can able to use this pin diagram to study the operations of the logic gates, and parallelly we shall verify the truth table of few of the logic gates. Clear? Okay. Thank you, one and all.